So welcome everyone, and thanks for having me here. My name is Luke, as mentioned, and I'm CTO at a company called Pulumi, but as was mentioned, I actually spent some time at Microsoft and at Amazon in my career before coming to Pulumi, and I really gained sort of these sort of two pieces of background. One at Microsoft, working on sort of software engineering and on tools for developers, building programming languages, IDEs, frameworks, that sort of thing for people working on top of the Microsoft platforms and helping them to scale with the complexity of the application software they were building. And then when I went to work on EC2 and AWS, I saw sort of this front row seat of the increasing and rapid adoption of complexity on top of the cloud platforms and how that was enabling businesses to move more with more agility, as the T-Mobile guys were just talking about, but also how it was bringing additional new challenges and complexities to how they managed their cloud infrastructure. And so today I want to talk a little bit about that intersection of those two concepts, the intersection of how we think about bringing some of the tools that we've built up over the last few decades around how do we scale up the complexity of our software engineering disciplines to the cloud infrastructure space, and how we can marry some of those tools to how we manage and deploy our cloud infrastructure. So there's sort of two things I sort of believe, and sort of the first of these probably is no surprise to folks in this room. I think the folks in this room who have been watching the cloud space for some amount of time are very aware that the sort of both the criticality of the cloud to their business and the complexity of the cloud within their business are both increasing at a rapid rate. And I think drilling down on this though, there's sort of three things I've personally seen that I think are really important to sort of be aware of as we think about how this trend is happening within organizations, especially as you get down to the individual teams sort of adopting these things. And the first is, of course, just like the T-Mobile guys were talking about, the overall migration. I mean, there's just enormous amounts of workload moving into the cloud, and so there's the complexity and benefits and value being delivered just by that overall migration, and we focus on that a lot, the net new coming into the cloud. But I think even once you get into the cloud, there's a lot of interesting things that start happening around how that complexity and the value increases as you become a more mature user of the cloud. And that happens in two ways. One, folks are moving up to more and more sort of higher level managed services. They're not just going, lift and shift to a VM and sticking with the same patterns and sticking with the same level of abstraction. They're actually moving up to higher level services, whether it's containers and serverless on the one hand, higher level managed data services, higher level workflow services, all kinds of things that move the level of abstraction they're working at up higher and higher, and therefore the complexity of how those building blocks are put together become richer and richer. And the second is that sort of some of that ownership that may have traditionally been inside an IT organization is now getting sort of pushed out throughout the organization. First into business groups who are building up their own IT organizations and their own DevOps teams, but then even into development teams as some of that infrastructure is actually versioning at the same pace as the applications themselves, which is a pattern we see with serverless and with some of these more container-based architectures, that ability to sort of deploy and manage cloud resources is actually permeating throughout the organization in a deeper way. And all of these lead to that sort of increasing criticality and complexity that the cloud presents. The problem is at the same time, the tools we have available to us to manage this really haven't evolved nearly as much as we maybe think they have. The tools that we were using sort of in the pre-cloud era or in the early cloud era are still largely the same tools that we're using. Some of them we have a slightly different tool, but they're still using a lot of the same patterns. And so relative to the sort of level of complexity that we're seeing, we don't quite have the tools yet to manage that and to scale with it in a really robust way. And this is what I really want to focus on today. And before I talk about the sort of tools themselves, let me drill in a little bit on sort of one of the big transitions I think we kind of see as we go from sort of pre-cloud or early cloud architectures to sort of cloud native architectures. And sort of on the left here, I think you see sort of the VM-centric kind of world. You've got a handful of VMs. You put your software inside them, you deploy it. And the interesting thing about this world was, in some sense, it's simple, right? It's just a few VMs. It's got the software inside. But the challenge was you were responsible for managing sort of everything inside those VMs. And so the cloud was sort of helping you with getting the VMs out there, but you were still managing everything inside the VMs. In these cloud-native infrastructures, we're taking advantage of more and more managed services. So we're taking advantage of S3 and Lambda and API Gateway and CloudWatch and what have you. And so we're taking advantage of more managed services, and so we're offloading more of that sort of operational complexity to the cloud provider. But it means our code actually reduces. So now we own some containers running in EKS, we own some code running in Lambda. But the really interesting thing is not that. The new thing that we also own is all these arrows. Right? We own how do we configure each one of these boxes? How do we tie them together? How do we explain the relationships between them? And in fact, when we think about what cloud infrastructure is today, whereas yesterday it was, I want to have 2 VMs running, right? That was my cloud infrastructure. And I wrote that one piece of YAML, and it was, now I was done because I had or it was a little more complicated than that. I had to define my network and things, but it was largely this. Now my cloud infrastructure is how I describe the entire topology of the different services that I'm using inside my cloud provider. And so that's where a lot of this complexity starts to come from. And that complexity is born of the ability to offload operational complexity, which has huge value for the organization. So getting to sort of some of the tools that we kind of have available to use today, really I think the amazing thing in some sense is how much of sort of cloud infrastructure is still really being managed even through just point and click in a cloud, in a console. When we go and talk to customers and organizations we're using, we still see a surprising percentage of their infrastructure is actually not even repeatable. It's something that they created once, either by running some one-off script or by clicking in a console, and so we don't even have that repeatable infrastructure. But I think the industry has largely adopted the view that reliable use of the cloud is going to require having repeatably applicable infrastructure, and that has been this trend of infrastructure as code. And that trend has existed, of course, well before the cloud, even in sort of pre-cloud space. But with the cloud, we've seen good tools here. All the cloud providers provide their own infrastructure as code solutions native to the platform, and then we've seen tools like Terraform and other things like that that sort of build on top of that and provide a multi-cloud offering. And folks may think, well, isn't infrastructure code, isn't this sort of the answer to that, how we tame this complexity? And in some sense it is. It's been a massive step forward. The problem is that it's not really infrastructure as code. It's infrastructure as text. All of these formats are they basically write a giant blob of text, YAML or HCL or some very sort of basic data format. And they've grown a few little features to, as all DSLs do, they grow little features to sort of help you if you need to do a little loop here or you need to extract out a variable there. They kind of build some of those in. But the problem is we're still sort of stuck in a world where the state of the art is, hey, I want to run a new VPC inside my organization. I'm going to copy paste that 1,000 lines of CloudFormation over into this other place. And that's the state of the art for how I sort of do my engineering, is to copy paste giant blobs of YAML. I copy paste this stuff from random places on the internet. And so I pick up whatever best practices they do. When those best practices change or when there's new features available in the cloud providers, I don't know about it because I'm not using a shared or reusable component around that. I don't test this stuff. I mean, I almost never find a customer we work with who is testing their infrastructure. And that's scary because this stuff is critical to their organization. Because they have these giant blobs of text, they don't feel comfortable even refactoring them. And so because they can't refactor and maintain the sort of health of the code base around these things, they end up in a world where there's one guy who understands how to do this work. There's only one person who feels confident they can touch this CloudFormation template or this Terraform because they have so much sort of domain knowledge about that particular thing, and they haven't been able to refactor it to make it a proper artifact. And so this is where we get to this sort of infrastructure as software concept, is really trying to go beyond just text and think about how do we bring in that notion of all these different software engineering tools we have into the cloud infrastructure space. And just as a quick analogy for that, one of the things I often think about when I think about this space is sort of back to like where software engineering was kind of before we had all of these modern tools for software engineering. And you sort of had this, the 30 years ago, 40 years ago, maybe 50 years ago, I don't know how long it was, this was the state of the art of how I built software, right? I wrote some assembly code. And this was actually amazing at the time, right? At the time it would have thought like I had this amazing piece of hardware, this CPU that I had available to me that is incredible, right? The building block pieces of that hardware enable me to do amazing things, just like the cloud today enables me to do amazing things. But as an engineer, having to work at this level was incredibly limiting. And that's something we can only really tell in sort of hindsight based on what we've built up since then and the complexity we've been able to build on top. But at the time, it would have felt like, oh, I'm empowered to use this CPU and do this computing, and I have these tools. And I think that's sort of the same state we're in with the cloud today. But if I look at this, I can sort of see a few things that are sort of clearly missing if I look in hindsight. There's no variables, right? So that's like a useful thing for being able to sort of share between things. There's no loops. I have to hand do that sort of thing. So if I want to repeat a certain operation multiple times, I can't do that. It gets more interesting when I talk about things like functions, right? The ability to sort of say, here's a piece of reusable code, and I want to write this thing once and then use it in multiple different places, right? Instead of copy pasting things around, I want to have reusable abstractions. That's a very useful thing. This core notion of abstraction, not just of functions, but of sort of creating reusable templates of behavior, whether it's at the function level or ultimately at sort of the class level and that sort of thing that we have developed. I don't have types, so I don't have the validation early on in my development process about correctness of my application. And sort of building on top of all of these, I'm redoing everything. I'm reinventing the wheel every time I sit down to write a piece of software because I don't have the C standard library, which gives me these common building block components at a higher level that I can use to compose my applications. And so I don't have that yet in this world on the left. And finally, and this was sort of not really a thing quite in this era, but like looking back on it, we don't have that IDE productivity. All these tools we've built up. Some of the tools I worked on at Microsoft that we've seen enable developers to move much faster, enable teams to collectively move much faster in building application software. We don't have those tools available to us to sort of understand the complexity of a code base and manage it. And finally, of course, testability. And so if I look at all of these together, obviously sort of the solution in that era was something like the C standard library, which gave me sort of all these things. And so the C programming language and its standard library. And these, by bringing a programming language in here, by up-leveling the way that people think about authoring their software and giving them a standard library to work with, they were able to embrace a lot more complexity here. So at Pulumi, we're building one tool that sort of tries to solve for some of these. And I want to sort of show off what it can mean to do sort of cloud-native infrastructure as software. And I'll use Pulumi to demo it. I'll talk a little bit later about how some other solutions in the space are also cropping up right now. No, that didn't switch. All right, perfect. Okay, so let me just really quickly show a couple of aspects of what we can do inside something like Pulumi. And so one of the key things is, like we talked about, the C programming language coming in and being a solution to how we manage complexity. In Pulumi, we sort of bring real programming languages and all the tools that they offer into the space of how we do cloud provisioning. And so, for instance, I can go to the AWS library that we have, and we just have an import here for the AWS library. And the AWS package here just has the entire capabilities of the AWS platform available to me. So I can come in here and say EC2 instance. I can come in here and say AWS S3 bucket. Everything that's available inside the AWS platform. And one of the interesting things there is, it's often easy to think that, probably no one thinks the AWS platform is small, but it's often easy to misunderstand how big these platforms are. I think this AWS package exposes nearly 1,000 different resources that are available within the AWS cloud platform. So it's an enormously broad platform that we have available to us to work with and build our applications on top of. And we have that all available inside this kind of environment. And so when I write this program, I'm saying I want to have a bucket. And now I'll just say export const bucket ID. Bucket.id. And now I can come down here and say, Pulumi up. And this will say I want to now stand up this stack and update it to match the description I had of my stack here. When I do this, we'll see it'll tell me that it wants to create a single bucket. Let me just make this a bit bigger. So I create that single bucket, and I can go ahead and say yes, and this will provision that inside AWS. It's a very kind of simple thing. The interesting thing, of course, is that this is not just running an imperative script here. We can say, acceleration status enabled. And one of the interesting things, of course, because I have the IDE here and things, and this is sort of going back to some of those benefits, I can get, help tips for these. I can get type checking for this. I get squiggles because I don't yet have correct code here. All these sort of core inner loop benefits I get to sort of using some software engineering practices. So now I can do that, set it to enabled. And one of the things we see is when I do a Pulumi update, we first do a preview of that and say what changes is this going to make to my infrastructure. So standard sort of infrastructure as code model where I want to make sure I understand what changes am I going to make before I go and update those. And so here we see we're not going to recreate that bucket. We're going to update it in place and modify its acceleration status to be enabled. And so now I can go and say yes, and we'll go ahead and make that change to my infrastructure. And so very similar to other infrastructure as code offerings, but we get sort of some of the benefits of JavaScript and TypeScript in this case to describe that. The interesting thing, as I talked about in the assembly examples, we can bring in sort of some of these sort of functions and refactorings and that sort of thing. So I can say create bucket, create accelerated bucket. I take a name and return a bucket. And now I can just refactor this code and make it a bit simpler, hide away that implementation detail. of the acceleration status on the bucket, and just create it down here. And you can sort of, I mean, this example by itself obviously is not particularly interesting. I just hid that one parameter in there. The really interesting thing about this is that I can now refactor and and sort of create structure and use all these sort of tools I'm used to for organizing my code. And the interesting thing is I did that refactoring and it didn't force me to change anything about my deployed application. I can do that as a safe refactoring to clean up and organize my application without impacting my actual infrastructure. So that's sort of a very simple example, but let me jump over into some things that sort of highlight, and I'll go very quickly through these, but just to give a sense of sort of some of how we can then go up to that more C standard library level. Once we have some of these basic building blocks of creating abstractions, we can now bring in a higher level model for how we work with this. And so instead of copy pasting around all my infrastructure, I could do things like, let's say I want a VPC. How many people here have stood up a VPC in AWS? Anyone? Okay, most folks have done this. So if you've done this, you've probably done something like copy pasting several hundred lines of CloudFormation, because that's sort of what the norm is here. Instead, we can just say, hey, we've got this network component in sort of a standard library. It exposes, as its help tip says here, it exposes several different variants and a number of different configuration options for how you can configure it, whether you want private subnets, how many availability zones you want to run in, what have you. But it's a really simple way to just pattern out those standard best practices for what you should do with a VPC that'll be kept up to date as you evolve and update to new instances of that. Similarly for EKS, the Kubernetes service, the managed Kubernetes service on AWS, incredibly powerful service, very useful for a lot of teams moving into cloud native inside AWS with Kubernetes. But for anyone who's tried to stand this service up, incredibly complicated to stand this up. We've talked to customers who spend a week trying to get this service running inside their AWS account and really not had much success. And it's because it's actually this combination of you have to do some things in AWS, then some things in Kubernetes, then some things in AWS, then some things in Kubernetes, and they have to all be stitched together in a very particular way. We can hide all that complexity again behind an abstraction. Do that once, build a robust library, validate it with tests as you would with any software component, and then give that to folks to use and work with EKS at a higher level. And so just with these few lines of code, I can construct an EKS cluster. And of course, you get all those same benefits, like let's say I make a mistake in this. I find that out immediately as I'm typing my code. Let's say I want to go and do some refactoring or hide this behind an abstraction. I can do that as well. So very easy to work with higher level things as we get up to this level. And then just taking one additional sort of example to highlight this. If we want to then go and, in this example, we're working with sort of ECS and Fargate and these sorts of services, AWS's sort of native container platform. And the interesting thing is here, again, that sort of we're at a higher level. We're able to think about the cloud platform, take advantage of the cloud platform in a more productive way, in a way that takes advantage of best practices, and in a way that enables us to use these things, these capabilities, these raw building blocks of the cloud platform more directly. And so in this case, we just want to run a container in production, right? It sounds like a simple task. Sounds like the kind of thing you draw on a whiteboard as two boxes and you draw an arrow between them. Then you go give it to your dev team and it takes them a surprising amount of time to get this done. And you're say, why? Why does it take so long? And it's because it's hard. It's the number of things you've got to stitch together to do this on AWS is actually surprisingly large. But here we show kind of doing this in 25 lines of code or so. And it's really like sort of each of the concepts that would be on that whiteboard drawing are one line of code. So we want to create an ECS cluster. That's one line of code. We want to create a load balancer to put in front of this thing. That's a couple lines of code. We want to create a Docker image in a private registry and push the image from the locally built thing up into that registry. That's another line of code. And then we want to create that sort of actual Fargate service, which is going to run the container scaled out to 5 instances of it, running this particular image. That's another handful of lines of code. And so this is sort of working more at that level of how your development team thinks about the cloud. But now they can actually work at that level because we've provided that standard library of tools at that level. So let me jump back into the slides and just highlight a couple more things here. So just sort of summarizing that last piece, I think one of the key things that sort of we see is this sort of mismatch between that sort of architecture diagram level thing. You see at reInvent, you see Werner put up these architecture diagrams of showing you how easy it is to use these services in AWS to build your applications. And it's true, and it's valuable, and it's important. But the reality of where most folks are today is that they're working at a much lower level of abstraction, at that assembly level, and not getting to benefit from just turning this kind of thing into something that really is a dozen lines of code or so. And that's one of the things we believe we need to do in the cloud platform generally to enable the productivity that developers have. As we look generally at that sort of list of kind of what are the sort of desiderata of bringing software engineering practices in, just re-highlighting a few of the things we talked about, types, really valuable. These provide sort of core correctness and bring correctness really close into the inner loop so that I'm getting that at my fingertips as I'm typing, not 30 minutes into deploying to production. I get that feedback early on. My IDE tooling, just the core productivity for my team to give them the ability to quickly build up infrastructure. That productivity has enormous value, and we've seen that in sort of the application development space. I think it's going to become increasingly important in the cloud space as well. Abstraction, talked a lot about the value there. And then I didn't talk as much about components and package management, but once we have abstractions, we want to actually publish those into package managers, version those things robustly, enable people to pull them down. We have a whole bunch of technology around this thing, things like NPM and Maven and all these things in the application development space. We really don't have these at all in the cloud space. And so really being able to piggyback on top of some of those tools, like with Pulumi, where we do it on top of NPM and PyPy, but really being able to piggyback on top of component models and package management is really key here. The standard library, I talked about some of these higher level standard library building blocks, and then testing in CI, I obviously didn't have time to demo that. We obviously can do that heavily for the components we build, but also our customers get to write tests for their infrastructure in a really natural way, using the testing capabilities of some of these software engineering languages. And so Pulumi is certainly not the only one doing this. I'd say there's two other examples I'd point out that are sort of really interesting in this space. One is Atomist, and actually Atomist's CEO kind of penned this software-defined delivery manifesto not too long ago, which I think is a really interesting read about some more general version of this problem, about how all of these critical systems that we have, from our cloud infrastructure back to the way that we do CI/CD and the pipelines we define, how writing these as YAML or very manually, not testing them, not having any of these software engineering tools, really limits the value we can get out of them and is really sort of not a robust way of treating these critical parts of our infrastructure. And so Atomists themselves are sort of really focused on bringing the same approach, but instead of to cloud infrastructure, to the CI/CD pipelines and how I manage that side of things, which is also really important. The AWS CDK, which is still in developer preview, but is being built by the AWS team. This is actually has many similarities to what we saw in the Pulumi demos. It's bringing a sort of a software-based approach using a variety of different languages into how I think about cloud infrastructure. And so even AWS themselves are sort of seeing this as the next evolution of how we think about defining cloud infrastructure. And they, of course, are building this as a specific thing for AWS, whereas with Pulumi and some other tools like that, we're kind of looking at it horizontally across all the different cloud providers. And so just to kind of summarize that, I'd say, what we see is these sort of core trends where the value people are getting out of the cloud is increasing rapidly, and also the complexity of how people are having to manage the cloud and manage their cloud resources is growing rapidly. And to scale with that complexity and to really harness, take advantage of it, enable all the people within their teams to benefit from it, we really need more robust software engineering practices. And at Pulumi, we're working on this, but we're really excited generally about the trend in the industry. So thanks a lot, and I'll take any questions if there's a few minutes.
All right, and I know you got shortchanged at the beginning, but
sure.
We're up against lunch too. So
we caught up.
Questions back here?
Great talk. Thank you very much for all experiencing similar problems.
Yep.
One of the things that I don't questioning if you just didn't have time to cover was the orchestration of the services themselves.
Yep.
So you said, hey, we own all these lines. And I was like, yeah, it's a mess. So does Pulumi offer services in orchestrating and managing those interconnections between the services? And what do you see happening in that?
Can you repeat the question?
Yeah, so I think the question was kind of about orchestrating in between all the different services and the relationships between those. Some of that you saw, some of these components that I showed off, these higher level things themselves are made up of several different pieces, and they sort of are orchestrating the way in which those components are tied together. So the way in which that load balancer is tied into that Fargate service, that sort of thing. Or in the Kubernetes example, there's a whole bunch of different components around the different IAM roles that are involved, the different the way those are embedded into Kubernetes RBAC, that sort of thing. There's a complex set of orchestration there that's all being hidden behind that thing. Certainly at the level where a user is stitching these things together, even if they're using these higher level building blocks, there's complexity just in the piece they have to write that is domain specific to their business needs. And Pulumi, obviously some of that comes down to code that team has to own, because it is about their application of this, not about a standard pattern. But Pulumi generally helps with, as you're building this software, kind of all the dependencies between those components are understood and are as you try to make updates, we're going to understand the right order to make those updates in, and if something gets replaced, we need to make sure we update everything else that references it to point to the new thing. We do create before deletes to make sure we don't have downtime by default. A lot of different things to help with the overall orchestration of rolling out changes to infrastructure in a robust and reliable way.
I guess I'll clarify, because where we're struggling is there's the infrastructure code,
Yep.
and there's also, as we're rolling out our own services, marrying up the changes that may be required at infrastructure level with our own services.
Sure.
And those services have to talk. So
Yep.
trying to manage both the Kubernetes containers with the infrastructure changes required and marrying those together.
Yep.
is a logical next step.
Yeah, so I guess the question was about marrying up the sort of versioning of the application changes and the versioning of the infrastructure changes as those things are evolving together and increasingly coupled. And actually, I briefly touched on it in one of those examples where kind of the Docker container that was being deployed in the infrastructure was actually, there was a line which said, build this image from this relative source path, push it up into my repository. And so in that example, Pulumi actually does triggers the Docker build. And so whatever, I can version that whole thing, which includes both my infrastructure and my application, and I can roll that out, and the Docker build and push will actually be orchestrated as part of the infrastructure deployment as well. And so now if I make a change where I change sort of the port that's being exposed in my application and in my infrastructure, I can roll that out in a safe way across both of those layers. And so we are looking at, there's that we're looking at other things which would help as well as even if you're decoupling those things more, like going through a separate CI pipeline for your application code. So definitely a space we're excited about.
One more? Everybody good?
So if you're doing any infrastructure as code, rather as text, YAML files or JSON files, we are using a lot of parametric values, right? Like we have so much configuration to fill in. Obviously, when we define that through code, we still have to have the code with so much parametric values.
Yep.
And it ends up becoming like one more AWS client or Azure client or something like that. So what's the difference between Pulumi and like AWS CLI or Azure CLI?
Sure. So I think the question was about sort of what is the difference between Pulumi and sort of the AWS CLI or Azure CLI, but I think the other was, just we have a whole bunch of existing complexity in sort of the how we're scripting together these existing tools. How does Pulumi? I think relative to any of the CLIs, I think there's the core infrastructure as code benefit, the repeatability, the ability to move from one state to another state reliably. These are critical things I think infrastructure as code offers generally, not just Pulumi, but infrastructure as code as a pattern provides, which if you're going directly against scripting CLIs can be very hard. And we've seen a lot of customers run into significant troubles with scripted infrastructure where now they need to move it into, or they have an instance that wasn't updated and now they need to update it and they don't know how because their scripts can't handle that. And so I think infrastructure as code is really a critical pattern for folks building reliable infrastructure by itself. I think Pulumi, generally in terms of sort of managing all the configuration that you were mentioning, I think Pulumi brings in a handful of features which let you sort of, if one piece of infrastructure you're building depends on outputs from lots of other pieces of infrastructure, instead of just manually wiring all that together, you can sort of, in a strongly typed way, point at the other piece of infrastructure and say, I want to get this output from that. And so now, even across disparate pieces of infrastructure, you've got sort of a sort of strongly typed connection between those. And so we're really looking, sort of holistically at how you put together these cloud applications and how you bring these software engineering benefits kind of across that. So,
good. Luke, thank you very much.
Great. Thanks a lot.
All right.
Thanks, everyone.